So in this video I'm going to discuss some characteristics of relational databases, and first of all we will discuss scalability. So database scalability is the ability to scale out or scale up a database to allow it to hold increasing amount of data without sacrificing its performance. Now what does it means that consider if there is a website with let's say 100 users, and as the number of users are less at that time, dealing with database would not be a big deal. But in case in future when the website grows and number of users increase, let's say the count of users goes up to 5,000 or 6,000, what would happen that the queries that we wrote in our databases would run slow, because there would be a huge chunk of data that we have to deal with, and in this case we have to take care of the scalability. Now in this term, scalability means that we have to process the whole data in the database but without sacrificing its performance. That means we have to process the data in less time. For that what we need is more computational power. That means that we need more CPU, more RAM, that our device can process the data quickly. And in case we should also take care that ensuring data is always available is the top priority for any organization, and minutes of downtime can result in significant loss of revenue or reputation, as you would have experienced in 20 August 2020. Google was down for, means not Google but some of the features of Google like Gmail, Drive and Docs were down for 6 hours, and many of the people suffered because of it. So in case any website or any application goes down, then it's bad for their reputation. So to take the care of scalability, what we do that we use two types of scaling. First is vertical scaling and second is horizontal scaling. Now what happens in vertical scaling, that there is one device, and in case we want to increase its computational power as the amount of data increases, then what we do that we add CPU and RAM externally to it. And one of the disadvantage of this vertical scaling is that there is an extent till we can upgrade that device because of the device configuration. But in opposite, horizontal scaling, now here nodes take part. Like suppose there is a database, and we have to increase the computational power of the device. So what we do that we bring more devices and connect to it, and as there are more devices, then all the computational power of devices are add up and the data is processed. Now one of the advantage of this horizontal scaling is that it's in our hand. If you want more computational power, we can simply add more nodes. If we want less computational power, we can decrease the nodes. And also this horizontal scaling is good for data security. For example, in case an hacker comes and tries to perform SQL injection, that means the hacker tries to mess up with the database with changing the rows and columns or adding his own data. So what happens in this horizontal scaling, there is a term called replication in cluster. So what happens that the devices replicate their data into another's device. So in case if we notice any attack, hackers attack, so we can understand that which rows and columns were changed by the hacker, and also by reverse engineering it we can also find the hacker. Now one of the disadvantage of this horizontal scaling is that the cost and the license cost. Because we have so many devices, we need more money for that, and also more money to buy means a professional license. But in vertical scaling, what we do that we just add up CPU and RAM for it, though it's limited, means we can extend the upgradation for a certain limit, but it's less costly. But in case in vertical scaling the device goes down because of any technical issues, then what would happen, that whole database would be down, and because of that the whole app or web application would be crashed. But in horizontal scaling, if one of the devices is down because of any technical issues, then another device can take care of it, and until the device is up. Because said that there is data replication, so another device can run its queries and process the data according to it. So secondly, we'll see that when should we use horizontal scaling and when should we use vertical scaling. Now what happens that first of all we will see the level of availability required. So that means that in case in small company would prefer vertical scaling, but a big company would prefer horizontal scaling because the cost is less, and it would be good for a small company. Also, as it's a small company, there would be no more, means there would be not large amount of data they want to deal with. But horizontal scaling is much safer, and though it's got costlier, but it's more scalable. And secondly, the type of application being deployed, and the third is accepted best practices within your own environment. So what I think over it that though horizontal scaling takes more money or more cost, but it's more scalable because we can change the computational power according to our comfort. So secondly, we will see the performance and efficiency. Now generally, slow queries or inefficient queries or long running queries are problems that regularly affect the database so that they are slow. So to avoid this problem, some of the main, you can say, solutions for that are always add a unique index to your table. Now what does that means? What does index means? That indexes are used to retrieve data from database very fast, they are used to speed up the searches or queries. And how they do that, it creates pointer where the data is stored within the database. And in case we go through the traditional way, what it would do, that it would start from the top and search till the end, and it would take more time to we can say execute. But as indexes use pointers, we can locate the data more easily. Secondly, understand the four fundamental resources, which are CPU, memory, disk, and network. Now most of the companies prefer servers with high CPU because as they have more amount of data and they need more computational power to process the data, so they prefer fast CPU. And generally speaking, each query takes single thread, means each query runs on single thread. What does this single thread means? That it would execute one command at one time. It would not you can say will be executed parallelly, means multiple statements would be not executed parallelly. It would take one command, and at one time one command will be executed. Second, memory. So as I told that if we have large number of data, we need more memory. And networks. Now what does network means? That in horizontal scaling, all the nodes, all the devices are connected through a network. So network is also important. If a network is destroyed because of any reason, then there would be some several issues. And thirdly, avoid using null in columns. Now columns means using null values in columns are totally fine in any databases, but if you are using columns into an index, it can affect query performance because of certain issues. And fourth is focus on scalability. As I told that if the number of users will increase, we will need to take care of the scalability. Now after that, we will see transaction. So a transaction in MySQL is a sequential group of statements and queries or operations such as select, insert, update, or delete to perform as one single work until that can be committed or rolled back. So what does this means? That these are means set of commands, and in case any one of the command is not executed properly, the whole you can say the process will be aborted. For example, we will take an example of bank transaction. So what happens that first, if any user want to send money to any bank, so to any another account, then what would happen that first it will check the availability of amount in the user's bank account. Then it will deduct that amount from the user's bank account and then update the bank account, and after that it will deposit the amount in second user's bank account and then update his bank account. Now if any one of the process, means there are total three process, if any one of the process is failed, then the whole transaction will be aborted. And this is what transaction property do. Now uh, there are certain properties that we need to discuss are atomicity, that means all or nothing transaction. Now this ensures that the statements are executed successfully, and in case something fails, then the whole transaction will be aborted. And secondly, consistency, that means guarantee committed transaction state. So database will change its state when the transaction has happened. For example, when the amount of money was deposited in the second user's bank account, then it will change the state. It would not change the state of its bank account before the money was deposited. And thirdly, the isolation, means like transaction are important. This property ensures that transaction unit is operated independently, and also it takes care of the transparency, that what type of transactions are done. And fourthly, we see durability. Now what this property ensures that the result of committed transaction persists permanently even there are any system failures. For example, any transaction is done, and in case any server is down, then that data, that updated data will remain same, and because of that your transaction would be safe though your server fails because of any technical issue or any scalability issue. So these were some characteristics of relational databases which are important, and hope you liked it, and that's it.